Hello everybody. So in this video we're going to cover somewhat of a mixture of concepts that we have not covered in our previous lectures or on the lecture slides. So some of the material or topics which may not be covered in the video lectures would be uploaded under the title of assorted concepts. So concepts that are important, that are useful, uh, but may not necessarily have been covered in the book. So one thing that we covered last time, if you remember, was the cout statement, which was the C++ equivalent of printf, and it was used to output some text to the user. Now, what we did not cover was how to input or take data as input from the user. So we did not cover the equivalent of scanf, which is called cin. So we're going to cover that today. But before we do that, let's first simplify this a little bit so it's less cumbersome to write. So we can write this as using namespace std. So we don't have to write this std double colon at the start of every cin and cout statement. And notice that instead of the stdio that we use in C, because cin and cout are streams, so we include the iostream library. So let's say we want to input an integer a from the user. We can do that using what is called the cin statement. One subtle difference: the arrows are in a different direction. So in the cout you use the less than sign twice, and the cin you use the greater than sign twice. So we put that here, and what we want the user to do is to input the value of a. Now, probably better to also tell the user what to do, so you might want to write something like enter the value of a, \n here. And so what your program will do is it will ask the user to enter a. So let's quickly go ahead and enter a. So let's say 100, and your program basically ends. It doesn't do anything with a. If you want to print the value of a, you can do that using another cout value of a is and you can either put a \n, or another thing that you can do is maybe put endl, which basically means end line. So that is the equivalent of \n in cout. So you can use that as well. So what it will do is it will take the value of a and then it will print what that value is. 100, the value of a is 100. Notice that you did not have to give a delimiter or specify a percent d here, as you would have had to with the printf statement. So C++ or streams are slightly, cout streams are slightly more smarter than the printf functions. Okay. So the next thing that we're going to do is to maybe input another integer b and print that as well. Generally, it's recommended, or it's good manners, to put your variables at the start of the program so they're easier to find and they're at the same location. So what we want to do is enter another variable. We're going to call it b. This is again an integer, so we can ask the user to input b and then print the value of b. It's pretty much identical to the previous statement, with the only exception that you are now replacing a with b. So let's do that. The value of a is 100, the value of b is 200. Okay, so not much new here. Now what we're going to do next is slightly new, and sometimes what we want to do is to compare variables a and b in a single statement, or put them inside two different conditions and check if one of the conditions is true or if both the conditions are true. So let's say if we want to check that a is equal to 100 inside an if statement, and we also want to check that whether b is also, or maybe b is equal to 200, right? So if we want to check something like this in an if statement, a simple way of doing it is using what is called the logical AND operator. And what the logical AND does is it basically is kind of like an AND condition. So you want to check if a is equal to 100 and b is equal to 200. So you're putting this condition, that you're putting in this requirement that both conditions need to be satisfied. So a needs to be equal to 100 and b needs to be equal to 200. So you can do that using the ampersand sign by writing that twice. So and then connecting the two conditions. You can also use this to maybe check a third variable as well. So you can add as many as you like. Maybe a is 300, so you can do that as well. But let's just keep ourselves to two variables for compactness purposes. So then maybe cout a is 100 and b is 200. So we wanted to do that only when this condition is satisfied. So it'll only print this statement when a is 100 and b is 200. If a is 100 and b is not 200, then it will not go into this body of the if statement. So let's quickly check this. And it says a is 100 and b is 200. Now if we give one of these variables other value, so if we say a is 100, b is 300, then it does not print that statement. So it does not print a is 100 and b is 200. We can do similarly for a. So let's say a is 200 and b is also 200. Then again it does not print that statement. Okay, and you can couple these inside different if else and else if blocks. So another thing that we want to check is maybe check whether the value of a is 100 or the value of b is 200. So either one of the two conditions is satisfied. So we want to do something like the logical OR. So we want to check if any one of these two conditions is satisfied. So we could do that using if a is double equal to 100, b double equal to 200. So instead of the AND, we now want to do a logical OR type of a comparison. So if either one of these conditions is satisfied, so or both can also be satisfied, but let's say OR. So this is generally done using these two pipe signs that you will find on your keyboard. I think these are right above the backslash. So on the same key as the backslash, so two pipe signs. These generally represent the logical OR. And what we want to do is, in this particular case, we want to print either A is 100 or B is 200. So one of these conditions is satisfied. Okay, so let's see if this works. And let's try this one first. So value of A is 100 and B is 200, so it went into the first AND statement. Now let's try it again, where only one of the conditions is satisfied. Maybe A is 100, B is 50, and so it says either A is 100 or B is 200. So the first condition, A is 100 and B is 200, is not satisfied, so it skips that. Then it checks is either A 100 or B 200, and we know that A is 100, B is not 200, so it goes in here. But again, why does it go in here? Because we need only one of these statements to be satisfied, and so it says either A is 100 or B is 200. Okay. Okay, the final concept that I want to demonstrate is slightly different. It's basically called constant variables. So let me first comment this part out. Sometimes you actually have to work with variables that do not change value. So, or you know that will remain constant and should actually remain constant. So let's say you want to define constant, maybe call it float. Let's say you want to define a variable pi. Actually, pi is a key word, so actually it's not, it's just input. So pi is 3.14149. Let me do a quick Google search to see whether I have the right values. Give me one second. So the Google search actually reveals that it's 0.14159, not 49. So we don't want this value of pi to change, right? And we in fact don't want anybody to be able to change this because this is a constant that we're going to be using in our calculation. So if anywhere during a program, let's say we get some bug, and at some point either we try to change this value or assign it a new value unknowingly, of course, or maybe someone else does, or maybe we've written the code in a way that this gets modified. Now if you want to avoid something like this from happening, then you probably want to use the constant keyword. So the const float basically means that if somebody tries to change this tomorrow, they won't be able to do this. So let's say I want to do, down here I want to say pi is equal to maybe 3.14149. 0.28 or something, and you will actually notice that you get these red signs under an expression must be a modifiable value or whatever. So let's try to run this and see what it does. Still want to build this. So it's saying that you are trying to modify this, right? So you cannot assign to a variable that is constant, so you can't change the value of pi. So once you have actually assigned this or made this a constant, then you cannot change it, and so C will not allow you to do that. So this is a useful concept, and it will come in handy. Of course, you can use pi for calculation. So let's say you want to define another variable, maybe float area of, maybe area of circle is pi star, let's say we want to a star a, so we want to calculate the area of that. We can do that. So C out area of circle. Okay, so there's nothing stopping us from using this in our calculations. It's just that we are not allowed to modify it at any point in our program. So if we run it, and if we run this, then, so let's say we want to calculate area of a circle, radius 2, b is whatever, area of circle is 12.566. So we can still use it in our calculations. It's just that we can never ever change it because we've defined this as a constant variable. Okay, if we remove the keyword constant, then we are allowed to change it. So it just depends on what you are trying to do.